Hi folks, welcome back to Physics with Captain Rod. I'm making this video here to help you out with number 15 here in what are we on here, Unit 4 homework. So let's see, a 12 kilogram meter squared disc has a radius of 60 centimeters and it's supported as shown, free to rotate. Now there's basically two different problems here, right? And I'm going to kind of separate them here. You have a problem on the left and a problem on the right. And let's talk about the problem on the left first. All right, so it says to find the acceleration of the disk, and that's referring to the angular acceleration of this disk. When this 40 Newton force is applied, this disk is going to start to accelerate this way. It's going to have an angular acceleration with it. So what you want to do is draw a free body diagram. That free body should have, let's see, 3 force vectors, right? We've got this one down that's already there. Okay, this object has a reasonable weight as well. And it is supported at this pin, right? So go ahead and draw your free body, and that's pretty well it. I can't think of anything else that we need to worry about in this problem. Now, let's talk about observations here, all right? The acceleration of the center of mass is going to be 0 because the pin is going to keep the center of mass from going anywhere, right? This object, this thing right here, isn't going to start accelerating in a translational sense, but it is going to have an angular acceleration, right? And that's what we call alpha. So after you get your free body done, write out the following equation. The sum of all torques is equal to I times alpha. Now, for this problem, it's going to accelerate clockwise. I would just call clockwise positive. So look at your free body now, and you should have 3 force vectors in it. And if you sum torques about this point, 2 of them will not appear in that equation. Right? Only this force vector will. And the torque created by that force vector is, right, the 40 newtons times this distance, which is given in the problem. Right, and the moment of inertia is also given in the problem, right? That's what that thing is. So that should get you the problem on the left done, no issues. Okay, so part B, find the acceleration of the disk if a 40 Newton object is attached to the rope and the system is released. So that's the problem over on the right, right? That's this one, whoops, this one. And you might think that, well, it's going to be the same, but, you know, as you can probably guess by the fact that I've even asked this question, it's not. It's not going to be the same, and let's talk a little bit about why. All right. First, draw a free body of this object. It should have 2 forces on it, right? The 40 newtons down, and then I'll let you decide on what the other force is, but I will tell you it's going to be up. And here's something to realize. That object, if you look at the problem, is going to accelerate down, and that means the net force must be down for that object. All right? That tells you that the weight, the 40 newtons, is larger than the other force acting on this object. And you can start to see right now that the tension in this rope, all right, is not 40 newtons. The tension is an unknown value. So again, getting to working the problem. So you draw a free body of this. Right? It should have 2 forces, and then write a Newton's second law equation for it. The sum of all forces equals ma. And I would do down positive because that object is accelerating down. Okay. Now let's go over to the disk. Draw your free body of the disk. It should have 3 forces acting on it. You've got this rope here. It's got a tension, which acts up on this object, but down here. Then the disk also has a weight, an mg, and it's supported at the pin. Write a torque equation now, after you get your free body done. Sum of all torques equals I alpha for the disk. Right? And this side should only have 1 term coming from the tension in this rope times this distance. Right? And then equals I alpha, the I we have from before, the 12 kilogram meter squared. All right, so at this point, you should have two equations, and you should see the following unknowns: an unknown tension, an unknown acceleration of this object, and an unknown angular acceleration. Okay, the tangential acceleration is related to the angular acceleration through the definition of a radian. So remember, we've talked about these three equations here. One of them is like s equals r times theta. When you divide by delta t, or in calculus we say if you differentiate that, this s becomes a v, and then the theta becomes an angular velocity. And if you divide by delta t again, or in calculus we would say if you time differentiate it again, right? Change in velocity over change in time is an acceleration. And then change in angular velocity over change in time is the angular acceleration. So long story short, you'll have your two equations that have these unknowns. Then you're going to use this to get rid of this. Then you will have one unknown. Then you should be able to find the acceleration and the tension after that, no problem. So, all right, hopefully that this little chat gets you through this problem. Hope that this helps. Have a great day.